there. My name is Janice Novakowski, and welcome to my pre-recorded session, What Math Lives Here, Investigating Mathematics Outdoors. This session is focused on kindergarten through grade 3 to 5. I'm from Canada, so I speak about grades, grade 3, grade 2, etc. I'm from British Columbia, the Vancouver area of Canada, and this is my first time presenting at this conference, so it's an honor to be here. I live right on the west coast of British Columbia, where the river meets the ocean, so where a large river flows out into the Pacific Ocean. And this photograph on my screen here is walking distance from where I live. So just wanted to share that from my walk the other evening as the sun was beginning to come down on the horizon. I would like to acknowledge that I'm joining you from the traditional, unceded, and ancestral lands and waters of the Hunkaminam speaking people, and honoring the knowledge holders in the community and elders that have shared their Indigenous knowledge and culture and practices as part of my learning journey about connecting to the land and the sky and the waters around me. My intentions for this session are to think about why outdoor learning is important for curricular learning, and you're at an outdoor learning conference, so I'm sure I don't need to talk too much about that. I want to talk a little bit how place can inspire mathematical thinking. I'm going to share 10 outdoor learning practices for math teaching and learning, and then I'll share specific examples from kindergarten and grade 5 classrooms. If you'd like to reach out to me after viewing this session, you're welcome to email me. You can also follow me on Instagram, and I have a website that is under development. So why outdoor learning? I like to share my why. Everyone has their reasons for why they like to take children outdoors. It has been a practice, part of my practice for my entire teaching career. I've been in education for almost 40 years now, beginning teaching preschool when I was doing my undergraduate studies, and we went outdoors every day. And I continued that into my primary teaching and then the work that I do with professional colleagues, supporting teachers in their professional learning around mathematics. So, in thinking about why, and if I needed to talk to colleagues or parents or administrators around that, one of the resources, our local resources, is an outdoor learning lab at the University of British Columbia, led by Dr. Mariana Bersani. And there's extensive research documented on her website and shared that talks about the many physical, social, emotional, cognitive, and health benefits from just being outdoors. And again, lots of key research across the world happening in this area right now. And then again, from an Indigenous perspective, Indigenous scholar Dr. Gregory Kaheti talks about coming to know a place. And I think that this is really important, that we're not just going outdoors to do things. We're actually coming to know the place and the phonology and the changes of the seasons, and understanding that a place holds story and understandings, cultural understandings that are passed down, through generations, and that coming to know has responsibilities attached, and that the stewardship of the land is really important. And then many of you will know the work of Richard Louv and nature deficit disorder and that Last Child in the Woods book that became very popular, and that idea that children need to feel connected to the world so that we can take care of it, and we need to get children outdoors more for lots of reasons. So those are sort of three of the ideas that I draw upon. I enjoyed a childhood spent outdoors, and made sure that my sons also had that, and they're in their 20s now, and continue to be outdoors people, skiing and hiking and surfing and cycling outdoors, so just enjoying being outdoors. And so I think nurturing that in our children is really important, to be a lifelong outdoors person. I also often refer, when talking to parents, many studies, I think this one was from North Carolina, with a large group of children, 10 and 11-year-olds, I believe, but several studies have replicated this, where they provided children with logos like McDonald's or Adidas or Nike, and children could identify more than 100 of those. But then when they asked about local species, plants, flowers, trees, they could only identify less than 10 on average. And I thought that that's very compelling. It talks about our media rich world and that important piece of getting to know a place by getting to know the species that we're sharing it with. So that will be woven throughout my session today too, about having children identify species and learn to name species as well. And then again, drawing on Indigenous perspectives, the idea that we're not just going outdoors, we're learning on and with and through the land. And that relational learning and teaching really centers Indigenous knowledge and perspectives. And so just want to make mention of that. And then thinking specifically about mathematics, regardless of what grade level you teach, pull back and really think about those big ideas in your math framework or your math curriculum, your learning standards, whatever they're called in your context, and think about where those concepts live outdoors. Where can we think about shape? Where can we think about size? Where can we think about symmetry, pattern, data, probability and chance, quantity and estimating? Regardless of where we go in the world, these are really the key math concepts in the elementary grades. And where might they live outdoors, or where could you have opportunities with your students to explore these concepts outdoors? I would be remiss if I didn't honor Juliet Robertson, who passed last year, and her book, Messy Maths, is just a book that I go back to over and over again. Her first book, Dirty Teaching, was also very lovely and just full of very practical ideas. And part of her legacy is that her website will continue on. So creativestarlearning.co.uk. And if you're not familiar, she's from Scotland and just has shared so many amazing things to get children thinking about mathematics and literacy and other curricular areas outdoors. I also want to share a local resource developed by my friend, Dr. Megan Zenny's doctoral research, and this was one of the products of her doctoral research. She surveyed teachers from across Canada, early childhood teachers as well as elementary age teachers, and she developed an outside play teaching tool. It's all online, it's all free, and it has different modules, just free modules that you can work through. You can use them for professional learning opportunities with colleagues. There's one getting started. There's one on, urban hazards. There's one on rural hazards. There's one on, teaching outdoors throughout the seasons or in the winter. And then I contributed to one specifically around numeracy and mathematics outdoors. So there's resources or short videos, but just thought I would share this as a great free resource in connecting curricular learning for elementary age children. In planning for outdoor learning, some things that I consider. First, safety and comfort has to come, first comfort with, children getting wet or hot or whatever it is for seasonal changes. So thinking about that really intentional planning and resourcing, making sure you have a first aid kit, a whistle, you have established call and response routines so children know when they need to come in. You have established meeting areas, line up and transition routines, that you have a backup of snacks and water and wipes and dry socks and gloves and garbage bags available as well. Those come in handy all the time. And that you have contact info for the school, your emergency info, the student info, and some sort of communication device. Many of us can just use our cell phones, but depending where you are, some schools are also using walkie-talkies just because it's easier to get in touch with the office at the school, for example. And then the importance of site inspections and audits when you're going outdoors and making sure you do a scan, your community and your context best, and what is necessary there to make sure that this is a safe place for students to learn. And then the other area around intentional planning is that, exploration and learning. What are you going to do once you get up there? And what tools and resources will support that? So having sit mats of some sort, clipboards, write on rain paper if you're not familiar with that. And we're very familiar with that on the west coast of British Columbia because it rains a lot. It's paper that doesn't disintegrate in the rain, and you can just use a regular pencil on it, and then it lasts. So having that type of paper and those notebooks and pencils, magnifying glasses, binoculars, measuring tools, field guides, specimen collection containers for temporary specimen collection, cameras and nature journaling materials. I like to collect old, digital cameras that families aren't using anymore. Children still love using them. And then you can upload them to your computer or whatever. And then nature journaling materials. And then as a teacher, that pedagogical piece in terms of preparation and intentional planning is your knowledge of the math curriculum, for example, and your repertoire of practices that you can bring to outdoor learning and a learning goal for each time that you go outdoors. Some of those, again, general ready-to-go materials. I often have a go bag, which is like a little backpack for small excursions, with the small first aid kits, always wipes and some extra water, a cutting tool and twine, because you never know when you might need those, a small flashlight, and then site-specific tools and materials, depending where we're going. And then the wagon for when we're staying out for a longer period of time, or maybe going a bit further distance and we need to carry more things, tarps, twine, rope cord, a cutting tool of some sort again, carabiners, clamps, S-hooks for hanging things in the trees, or what you have access to, tarp pegs to hold things down, sidewalk chalk and clay, or other materials, natural materials that you can use outdoors. And I always, preface that, even with sidewalk chalk, to make sure that it's non-toxic, that it's not going to contribute toxic chemicals to the environment, a small shovel and a flashlight again. So just some of those ready-to-go materials that you always have, and then you add other things depending on, the learning that is happening. And I'd like to share a little bit of some of my inspirations. I've been fortunate to visit and be on a study group at the schools and centers in Reggio Emilia, Italy. And this is just an example of one of their outdoor spaces. You can see some condos being built in the background there, but just in one of their little piazza areas outdoors, a concrete area. They've got pallets and they've got donated marble tiles from the construction that was going on. And you can see planks of wood, and then rocks and cones and other natural materials that students create with. And again, just by the way that they're offered to children, provides what's called often a provocation for children to investigate or create designs that inherently have mathematics embedded in them, whether it's shape or pattern or symmetry or comparing sizes, etc. And then the other thing that has been a real focus of my work and my research in the last 10 years or so is really helping students and teachers and families widen their math lens in terms of thinking about what mathematics is and where it is in our daily life and the world around us, and how it helps us to understand ourselves and the world around us. So these are just some photos I took on a recent walk in my community, and the horsetails are coming up right now, and there's two different bodies of horsetails, and I think the growth patterns are really interesting in those for students to compare heights and look at the patterns and the distances in each segment. And then it's the time of the salmonberry blossoms. So April here is the first sort of berry blossoms that appear, and then they fruit in June. And again, they have a lovely 5-petal structure that are kind of triangulish. And you can see the fruiting body beginning in the middle, and they have some symmetry to them. So those are always, again, that's how we identify the salmonberry blossom, by its color, but also that it has 5 petals that are pointed like a triangle, etc. So, and how the leaves grow on the salmonberry bush. And then you can see some human constructed mathematics on the right with the little bridge and the shadows and the reflections, and how can we decompose a rectangle with triangles, and some examples of that. And then that juxtaposition in this photo on the right of the human constructed cylinder on the bridge And then the cylinders, the logs that have come up on the river, off the river onto the beach, and playing with that idea of what makes a cylinder, and those sort of geometric terms we talk about, and then more naturally occurring shapes and how would we describe them. And then the bottom photo is just a screenshot from a little video I took of the ducks in a pond near where I live. And again, the math stories that could come from that, like how many ducks are there? How many males? How many females? And then they're going in and under the water and swimming away. And, for young children in particular, it provides a context for them thinking about quantity and the math stories that they could create and tell from their context. So that's just, I want to share some examples there so that you can sort of see where some of this is going in this session. So outdoor learning in math, I've been thinking about this and talking about this for a long time, and I really has sort of synthesized that there's three perspectives. We can take typical classroom learning tasks outdoors, just like we can take a book that we're reading indoors and we can read it outdoors. There's still a benefit to just being outdoors doing that. So we can take a math game with cards and dice that we do indoors and we can do it outdoors, and that's great. And that's sort of that first step. And then the second one is we can connect our classroom learning to the outdoors. So some of those routines that we do in the classroom, like counting collections or measuring tasks or which one doesn't belong, we can take those outdoors and use resources from the outdoors to engage in that type of, mathematical learning. This is also where outdoor education often comes in, is things that you might do in a gymnasium inside using a compass, or some of those outdoor education type games comes into, we can do those outdoors obviously as well, that orienteering and the mapping and the using a compass and playing predator and prey games and those types of things outside. But it's really building on curricular learning, but using the outdoors as a context. And then the final perspective is really being inspired by the outdoors and the environment to help us think about mathematics in new ways. And this is where we can ask, what math lives here? What math story does this place tell? And so I'll share examples of all of these today. So many of you will be familiar with SPLAT. If you're not, it's an amazing mathematical instructional routine originated by Steve Wyborny, very similar to Bears and the margarine tubs. If you're familiar with Math Their Way from years ago, it focuses on algebraic thinking and finding the missing part. So for example, on the one on the right, the little 18 shares that there's 18 blue dots, so we can see 3. So we have to figure out how many are under the splat. So again, there's lots of different ways that students could figure that out. They're using their understanding of addition, subtraction, relationships, etc. When we have multiple splats, when they're all the same color, it's the same quantity under each splat. So this would be 3x plus 4 equals 22 for children that are able to think that way. But it could also be 22 take away 4 and then divide that number by 3. So children understanding that relationship between operations. So again, very common to use in the classroom on slides or with magnets and a construction paper splat, but then we can also take that outdoors. So I have all these little felt splats because the felt holds up really well outdoors, and then children can collect rocks or twigs or acorns or chestnuts or cones, whatever they can find outdoors, and create their own splats. But you can also just use a big leaf, or in one case that I think I share later, a piece of bark that the children found on the ground, and that became their splat. So again, taking those routines that we do inside and then just using, the resources that we have outside to, extend that thinking. Which one doesn't belong? Again, another very familiar mathematics instructional routine housed at talkingmathwithkids.com, as you can see on the bottom, but lots of resources online. But again, we can do that outdoors as well. So a lot of you will have 4 squares out on your concrete, and you can use those existing 4 square structures to do WODB, but you can also use sidewalk chalk. And you could use quantities, or you could draw things, or in this case, the children were comparing the shapes of the leaves that they found. Counting collections, another really common mathematical routine in the classroom where a pair of students count a collection in multiple ways and then record their count. And again, that can be done outdoors. So on the left, we see children collecting sticks and then using 10 frames to record and organize their count and then record with sidewalk chalk. You can also see little clipboards that they were recording on. And then on the right, finding a natural counting collection, estimating how many buttercups there are, and then realizing that all the buttercups have 5 petals. So then counting by fives to think about how many petals there are. And that just sort of naturally came about when we were outside. The routine clothesline, again, indoor examples here where children are comparing and ordering numbers and providing their reasoning as to why some go before or after other numbers, and then taking that outdoors. So again, on the left, comparing from length, longest or tallest, to shortest, and then measuring color from yellow to like lightest to darkest, and having children think about how we measure color and put those in order. A routine that, and a mathematical structure that I've been using a lot over the last couple of years is concept circles. And it's really been popularized by Canadian researcher Dr. Kathy Marks-Krpan from OISE. It originally comes from the work in English language learning development and to support vocabulary development. But again, it can be used so many different ways for mathematics. Excuse me. I think most of the examples I'm sharing are around number, but you could also share them for patterning. In the center of the concept circle, you could write AAB or ABC, and then each section of the circle, students could create different examples of that kind of pattern. But this is what it looks like. You could do 8 sections. I often start with just 4 sections. I can do large ones for groups of students or individuals, like on 11 by 17 paper. Here's an example on the left from an indoor one in a kindergarten classroom where I just used mural paper and I just quickly drew a concept circle, and children used materials that they found in the classroom to represent 7 in different ways. And then on the right, you can see we did the same thing outdoors, just in the courtyard. This is where I had 4 sections. I drew it with sidewalk chalk. And again, children used materials that they found on the ground. We talk about not picking things off of living species, living plants and trees. And they use those found materials to represent 5 in different ways. Again, some more indoor examples, just to sort of show you how concept circles can be used across the grades and in lots of different ways. And then some more outdoor examples. The concept circle on the left is probably the size of a dinner plate. And the one on the right is probably the size, it's quite large, probably about 1 meter across in diameter. And these are just on painting, like canvas painting drop cloths that I got at a store called Canadian Tire, but like maybe Home Depot in the States would have like that type of a thing. And I just cut them out and I used Sharpie to draw. Like I just free-handed the circles. I wasn't too fussed about it. You could also use acrylic paint to make them, and they hold up really well outdoors. And they, because they're flexible, you can use them on different landscapes as well, and they don't slide around. And then I can just throw them in the wash if they do get really soiled. So again, I have some wooden numbers that I use on the right one there. The student has used twigs. They made a 7 out of twigs for the symbolic notation in the middle, and then again, different representations of the numbers. And then same idea, we didn't draw circles, but at the beach, just using sand or mud and a stick to represent numbers in different ways. And we know, from the cognitive science research that representing numbers in multiple ways is really important for students understanding or developing numeracy or number sense, that deep understanding of a quantity, and being able to use that quantity flexibly and compose and decompose it in different ways is really connected to these representations. So again, an example for 5 on the left and a fraction on the right, and the fraction having the different forms, the area model, the set model, the linear model of representing fractions, and drawing on the 10 frame for the 5 and the tally marks and the dice dots on the dice as different examples. So just another way to sort of connect that idea of concept circles, but playing with that outside. So at that, I'd like to invite you, I've been sharing lots of ideas now, but I invite you to think about a place or space around your school or center, and what opportunities are there to see math or think about math or do mathematics. And if you're watching this as a video right now, you could pause right now, maybe just think about that for a minute, jot down some ideas so that we can intentionally plan for some of these opportunities outdoors. And again, just to sort of provoke your thinking, these questions: what math lives here? What do you notice? What do you wonder? What connections are you making? This is a photograph from Whistler, British Columbia. Some of you might know it as a ski resort. This is in the fall, so before the snowfall, and so the rivers are running and the trees are turning golden, and just a beautiful time of year to be up in the mountains. So, what ideas come to mind? You might estimate how many trees there are, and that's often what children start with. It's like, well, how many trees are there, or how big are the mountains? And then the layers start to come in, and this is why I like to give them those prompts about what do you notice? Like, oh, well, which direction is the river running, and where does it start, and how long is the river, and how deep is it, and how fast is it? And what lives in the river, and how many different species live in the river? So all those questions that can start to come up around an environment or a space or a place, by giving them some of those prompts to do some noticing first and then some wondering. So just again, using an image or a photograph or a map to do a bit of a math talk to begin a lesson. So thinking about how place informs questions and inquiries, and also wanting you to think about how does the land, water, and sky inspire mathematical thinking. So these are questions I keep coming back to in terms of that third perspective, in terms of having the land and the water inspire us to think mathematically. So I've just collected, these are images from around British Columbia, for those of you that might not be familiar with our province, and the range of different habitats and environments that we have. And again, I often share these with teachers and ask them to think about what mathematics comes to mind. And again, giving some time for that and thinking about what math lives here, what questions are coming up for me that I can use mathematics to think about this, or solve a problem, or solve an issue, or investigate an issue. What mathematics might I need to think about that a little bit more? And I guess this, to me, contributes to this whole idea of how might the teaching and learning of mathematics be more holistic and relational. And that language is really drawing upon the First Peoples principles of learning in our region, and thinking about how that sense of place can also be nurtured through the teaching and learning of mathematics. So that really relational thinking about place and relational thinking about mathematics to make it more holistic. So one of probably the most quoted researchers around cultural mathematics and an Indigenous perspective is Alan Bishop. And he identified 6 areas of human activity that embody mathematical thinking and occur within all known cultures. So measuring, whether it's with our hands or different unit reference, locating, which is like travel and mapping, using the sun, the stars, landmarks, etc., distances, playing, so games, structured games, as well as imaginative play, counting, is something that exists in all cultures. Different counting systems, that's a really interesting thing to investigate. And then designing, this is where architecture and design and art come in, and where we see symmetry and shape and size and measurement becoming important mathematical concepts. And then explaining, and this is really about how we discuss things and justify and teach and learn, and the language and the vocabulary and the gesturing that's involved with explaining. So again, I invite you to think about local connections to cultural practices in your area. Where I live and work, the cedar is considered the tree of life in Indigenous cultures. And we have the Western red cedar growing here. And this is on my backyard on the left. The little cones is one of its distinguishing features. And children often say, well, those aren't pine cones. I'm like, no, they're cedar cones. And, that's one of the ways we can identify the cedar as opposed to other species of trees. And then on the right are some examples of cedar weaving that I have had the honor of learning more about with an Indigenous weaver, Jessica Sylvie. And these are mats. And again, you can see, there's pattern, there's size, there's measurement, there's design embedded in not just the product, but also the process of that cultural practice. And all the mathematical thinking that goes into that. So think about, local connections for you and where you might be able to bring that into your classrooms or outdoors. This is from the interior of British Columbia, which is a little bit more deserty and has a longer winter than on the coast. And they have tule, which are kinds of like reeds that are used and dried and woven for mats and in houses and for blankets and such. So that was from a museum in Oliver. And so just want to share that as another example. And again, the mathematics that goes into the process of drawing and creating, and then the product that you can see there as well. And then this was from a recent visit to a coastal town on Vancouver Island. And again, thinking about designing. And, in these totem poles are often sort of overgeneralized. We don't have totem poles in all regions of British Columbia, but in the more northern regions we do. And then we have house posts. In more of the coastal, like south coastal area. So here are some examples of house posts and poles. And again, thinking about shape and design and pattern and symmetry and size and scale and all the mathematics embedded in creating something like this. All right, I'm going to just pause for a sec. You can take a breath too and write down some notes. I'm just going to have a little drink here. Okay, so for this last set of the session, I'm just going to very quickly talk about 10 practices for teaching mathematics outdoors. Many of these practices can be used for across different areas of the curriculum, but when I work with elementary teachers, these are the things that I really focus on for getting teachers started in making those connections to mathematics. I do want to note that nature journaling and observational drawing are a part of almost all of these. And so I don't sort of see them as something separate. It's like just something that we do. If you're not familiar with wildwonder.org, they have some wonderful resources for nature journaling and some downloads of this little quick start to nature journaling that is printable, and it comes in multiple languages, which is great. So this is an example. I mentioned the salmon berries earlier, and these were kindergarten and grade 1 students that were doing observational drawing at the end of the school year of salmonberry branches and blossoms that we brought into the classroom. So first of all is math walks. We all do nature walks or different types of walks outdoors. So a math walk is just a very subject-specific type of walk. Again, it could be what math do we see as our first walk to sort of set expectations. And then they can become more specific. Students can have clipboards, or again, they could be taking photos. And then when you visit a familiar area over time, students notice those seasonal changes and learn the phenology of the plants and species in that area. Again, those prompts, what do you notice? What do you wonder? What math do you see? What math lives here? And this is just one example of a shape walk. We started at the outside entrance to the school where there was a mural created by a local Indigenous artist and her family. And so we talked about the different shapes in there that are more organic and curved and more natural looking than maybe our geometric shapes. And then we looked at the school garden, and you can see the students had clipboards, so they were looking at things from a distance and then close up as well, looking for mathematics, looking for shapes. So ovalish or circle-ish or triangle-ish, there were lots of ish kind of words that they used, and that they sort of drew an outline in terms of what the shapes of different trees and plants look like and leaves. Again, as we go on a math walk, once students have identified some patterns and shapes, and we've done some of those specific things, and they have a better understanding of the place and have more experience with it, that's when you can start adding these questions, which are a little bit more, it takes some pause and some thinking and some discussion. Where does mathematics live in this place? What mathematical story does this place tell? And you might need to, fill in some of those gaps in terms of what this place looked like 100 years ago, what this place looked like 1,000 years ago. What other species share this place with us, and what are the stories that might happen when we're not here. Children love thinking about what the animals are doing when we're not walking through different areas. Sit spots, another really common practice for outdoor learning. This was, again, when I was a teacher librarian. I did outdoor learning preps for the kindergarten and grade 1 classes in my school. And once a month, we went down to the local pond, and the children all had the same sit spot, and they sat at that spot, and they did their observations from that spot. In this case, they're recording in their notebooks, but sometimes it's clipboard. Sometimes we don't take anything. It's just sort of being present, or it's a listening sit spot, or different types of sit spots that we do. But just an example of using a sit spot to get students connected and present outdoors. If you're not familiar with this children's book, Me and My Sit Spot by Lauren McLean, a colleague of mine here in British Columbia. It's available in English and French and Spanish. And also she has a teacher's guide around how to teach sit spots, and lots of ideas for using different sit spot ideas throughout the school year. Another routine that I use is Notice, Wonder, Connect. Often during math walks or during sit spots, we'll take photographs, and then we'll do that in class where we look at those photographs on a screen, or I'll print them out, like in this case, and ask students, what do you notice? What do you wonder? What connections are you making? And then provide time for students to investigate their math questions. Here's an example of when I took a class out again to Steveston Harbor near the river, and talked about the story of this place, and students took photographs. And on the right, the students taking photographs of the T-ball on the back field, the little T-ball area, the diamond, I guess it's called, and the math that's involved in T-ball. And, they did some math stories and some math problem posing around that. Also, when we were doing that Notice, Wonder, Connect, when the students were taking photographs, we created some panels to put up in the foyer of the school, to sort of, again, broaden that thinking around what math was, not just for the students and the teachers, but for the families in the school as well. So where do we see math outside? Where do we see math? And different pictures that the students took. And then some of the grade 1 and 2 class did a shape book. So they did all their pictures around shapes, and they had little phrases like, how many triangles can you find in this picture? Or they had a little I spy this, I spy that, to sort of guide the reader through their different photographs. But again, these books were published with a local hardcover publishing company, and then we barcoded them and had them in the school library so that students could sign them out and take them home to share with their families. Again, some more panels from grades 1 and 2 students that did math-specific walks. So a number walk, a pattern walk, and took photos. And we created those panels again to elicit discussion and excitement about mathematics at the school. Again, some follow-up there around the Notice, Wonder, Connect, and questions that they have. And again, an example, just this photo was put up on the screen, and we talked about how does this photo inspire you to think about this place? What stories live here? What connections are you making? And then some of the math questions that they posed. When I look at boats, I wonder how they know where the fish are. Which way do the waves go? I wonder how they catch the fish. How fast can the boat go? And again, those questions, many of them could be investigated by asking an expert from one of the families that are involved in the maritime industry in this community. Another example of that sort of getting out and doing a little math walk and noticing and wondering. We did that question, where does math live outside? And this was a little brainstorm we did before we went out. And then we kept adding to that as the weeks went on. We left a section of the whiteboard where we continued to add to that as students, again, broaden their understanding of what mathematics they might find outdoors. Treasure hunts are a fun way to get students paying attention to details and applying mathematics. I think it's just, a reminder to, it's not a race. It's, and they shouldn't be, again, picking anything off of trees or whatever. Often we'll just do a photo treasure hunt where they're taking the photos of the things or drawing them on clipboards. But in this case, I had a little printout, and the students worked in partners, and they're like, Can you find a leaf that is about half orange? Can you find a leaf that is about the same size as the width of your palm? And so that they were using mathematical vocabulary and concepts relevant to their grade level. And so I had different ones for different grade levels. And that was our math time outdoors that particular day. Another one at the beach, can you find? And then collecting those things and then putting them back where we found them afterwards. This is again another example of, where can we see and find mathematics outdoors? This is with grades 2, 3, and 4 students. So again, having a pre-talk about what is math, and then again, doing that sort of treasure hunt for math outdoors. And this student was explaining all the math that she found in this leaf. And this student had collected all these different leaves and laid them out and was comparing them. They're all different colors, they're different shapes, they're different sizes, the lines of symmetry, etc. So talking about all the mathematical details in their little treasure hunt there. The student found some Douglas fir cones and talked about the mathematics, the symmetry in the seeds, the diagonal pattern going around the cone, and then the triangular shape of the cone itself. And this student's little math treasure hunt was like, Miss Novakowski, I have a handful of math, and had a mathematical reason for each of those items that she collected. And then extending that sort of treasure hunt about where can we find math outside. This is with the grade 3 and 4 class, more connected to their curriculum, was looking specifically at increasing and radiating patterns, and then symmetry, lines of symmetry. So the students were invited to find the materials on the ground and then create designs that showed their understanding of patterning and symmetry. Some of them recorded as well, and some of them went 3D and lifted it off of the ground. The practice of sort of outdoors, indoors, spending lots of time outdoors, but sometimes, we spend time indoors as well. So it's bringing some of those things from outdoors into, the classroom or a studio space where children can spend a bit more time with them, use some different materials and tools that maybe aren't conducive to using outdoors, and then returning them outdoors after their temporary use. So different ways to bridge the outdoors into the indoors, using photographs, using maps, using specimen collection, etc. So here's a little bulletin board area, photos that we took on walks in the fall. And then a study of pattern that we did with all the K-5 classes at this school. And so we've got, the mathematical experiences around pattern, and then the indoors experiences, and then connecting to the outdoor experiences and those materials as well, and a bit of a collection happening there on the counter. And then this is in the little atelier space or artist workshop space where we brought in some leaves, and we have, watercolor paints out, and, having students focus, with the magnifying glasses and the mirrors and the prompt there on the little easel, like, what do you notice about size and shape and symmetry in these leaves? Not, children often just focus on the color, but let's have them zoom in a little bit and think about these mathematical concepts and the structure of the leaf. Using photographs. Again, this was from a math walk that we did in the neighborhood. These were older students. And they were looking at classifying species and looking at ecosystems. And again, some of our little specimen containers. And then we used some digital microscopes to look at them a little bit more closely. So again, that sort of outdoor, indoor, there are some microscopes that we can use outdoors, but we can't project them in the same way for the whole class to see without bringing them inside. Land art is one of my favorite practices because it embeds so many things. So many mathematical concepts. So using natural debris that you find on the ground, and it's really meant as sort of ephemeral or temporary art that is left behind. We have learned that, not to stack things because it's disruptive often of small animals' habitats and isn't safe for some animals. So if we do stack, we make sure we take those stacks down afterwards and leave them flat where we found them. So if you're not familiar with land artists, Andy Goldsworthy is probably the most famous land artist. He has lots of books and videos, YouTube, lots of things available there. Alison Tyler is from New Jersey, and then James Brunt is from the UK. And he's very prolific, not just on Twitter, but on Instagram as well. So this is Alison's work where she does these little tree ladders. So comparing and ordering the length of twigs, she finds twigs on the forest floor near her home and breaks them and finds little niches and crannies to create these little tree ladders. James Brunt on the left, I use his photographs all the time as inspiration with students. He has a beautiful book out called Land Art with lots of lovely examples. And this is an example from the Oliver area here in British Columbia, where there wasn't a lot of natural debris on the school playground. They had a cliff beside their school playground made of shale, and so those pieces of shale often fell down, and students gathered those, and they used those and leaves, which is really all they could find to create with. And you can see the spirals that they're creating here. This is an equidistant spiral, so they're using the leaves to make sure that those spiral turns are all equal distance. And then just again, these were grade 2 and 3 students. These were some of the math creations that they made outdoors with the access to the material that they had. And they loved how that I created a little collage of them, very similar to what they had seen from James Brunt's work. And then James Brunt does the 100 Leaf Challenge every fall, and he challenges children across the world to find 100 leaves and to create something with them. And so I did this with a grade 2 and 3 class, and this is one of their designs that they made. Looking closely, really important practice outdoors. Again, getting kids to slow down and notice details. Lots of descriptive language development, but also identifying attributes of different species as well. So magnifying glasses, microscopes, digital microscopes, different measuring tools can help here as well. And again, that observational drawing that often, comes alongside looking closely. Some beautiful book series that focus on looking closely outdoors. Looking Closely series by Frank Serafini. Beautiful series in different contexts, and then One Small Square. Again, that idea of taking either a 1 foot square or a 1 meter square and just spending time observing and looking closely at that space and what happens in that space. So this is an example. We looked at some of the images from looking closely in the garden and then went out into the school garden. These were grade 2 and 3 students, and they recorded some of their observations. And you can see that the student on the right there in her notebook, she's added the little magnifying glasses to show in the zoomed in part, but they included measurements, they included drawings and descriptions of what they look closely at in the garden. And then these were some photos that students took with iPad tablets, and again doing a sort of a zoomed out photograph and then a looking closely, like zooming in and looking at something zoomed in, and then they played a bit of a guessing game by just showing the zoomed in image such as this one and asking what is that, what could that be from. And again, lots of sort of literacy and language things that you could do alongside that. Again, photo books, great. And then you can see the example here. This is students using old digital cameras that families are happy to donate and take their photographs with that. And then again, just a bit of documentation here. Here's the tree, here's the leaf, and then here's a zoomed in look at that leaf as well in those details. And again, spending that time to look closely, and then how would we describe that? That's the student language. This is just cardstock or manila tag that I cut frames out of. You could use mats from frames or cardboard. This is just what I had available for this class, and we went outdoors and again did that sort of 1 small square or 1 small rectangle and spent a good block of time just observing either what was happening on the tree with the bark, because there were lots of ants, so the students were excited about watching those, or the the little groupings of mushrooms and seeing what was happening there. Again, looking closely at how plants grow and how they grow often in patterns along the stem. The leaves often grow either opposite or alternating or whorled around the spiraling around the stem. And again, you don't really pay attention to that unless you actually stop and look closely. And then connecting that to the use of field guides, when we look closely, we notice the difference in the patterns in different moths and butterflies and bees, wasps and hornets, etc., or ants or beetles. And those subtle differences about the patterns that those animals have helps us to identify which particular species they are. So that's a lovely connection to using field guides. Go bags are, again, that sort of collection. I talked about this earlier. Just things ready to go. Again, field guides, some measuring tools, some resources that you might need specific to where you're going. And so, in our context, it's like when we're going to the forest, what might we want there? We might want some measuring tools. We want some tree and mushroom field guides, for example. If we're going to the beach, we're going to have different tools that we want to bring along. We have different kinds of field guides, seaweeds and sea stars. And then we have different, like we have sieves for the sand, and we have graduated cylinders to, pick up some seawater and make some observations there. And so you can see the different tools that we might have in the go bag depending on where we're going. And then, of course, a go bag for going out into the garden too, measuring tools and digging tools, etc. So field guides, I've mentioned these a few times. I have a huge collection. When I travel, I always try and find a local field guide. I love getting them in different languages, including indigenous languages, to sort of build my knowledge and understanding of different local species. But again, scientists use mathematics to help them identify species. And so that's drawing students' attention to that as another reason why, mathematics helps us understand the world around us. This is an example from a grade 2-3 class where we looked at different types of field guides, and then we decided this class was going to create their own field guide for some of the trees at the school park. So they went out and they took pictures of the trees. They did, again, big pictures zoomed out and then zoomed in pictures of the leaves. They measured the circumference of the trunks of the trees. They measured the length of the leaves and the width of the leaves. They did a little bit of modified trigonometry to estimate how tall the trees were. They recorded all their measurements, and then we typed those out and then included them in a little field guide that was available at the school office when visitors came. So we only have them from the spring. The students said it would be good to have like a winter version because the trees, especially the deciduous trees, look so different in the winter. And again, these are local field guide resources here, but I, encourage you to look and see what's available in your community, in your state, in your country, in your province, to help you, learn more about local species. And then the last practice I just want to share a little bit about is studio experiences. So I, was fortunate to have a math studio where children came for math experiences and teachers came for professional learning. And, again, how do we take those studio experiences outside? So what materials and tools can we offer outside for students to think about creating and making mathematics? Or to explore a mathematical idea like pattern or shape or symmetry. And so these are some of my favorite books for those sort of studio experiences outdoors. A lot of them explore pattern. And then there's my wagon that's loaded up with different things depending on what we're doing. And just some examples of, studio experiences, lots of jumping in puddles. And then again, how do we record or capture that essence of those concentric circles that the students were jumping in the puddles with, and using sidewalk here on the concrete, using different tools to measure the depth of puddles and having access to different tools. And then again, you saw this earlier with the clothesline, but how can we play with color and think about measuring color in different ways in the fall with all the different leaves that are on the ground. So that was, again, playing with a studio idea like color and taking that outdoors. Some materials, some clay, some rhododendrons that I collected from my garden so that students could have some nice juicy flowers to do Japanese flower pounding with. And again, some land art books for students to be inspired by. And you can see there that Japanese flower pounding to sort of capture the pattern and shapes of the different flowers. And then using natural clay to create imprints, to look at symmetry and pattern and design on cones and leaves and twigs and bark, etc. There's some examples there. And then the shadows and the shapes of the tree branches, fractals, really important idea in later mathematics, but it's a type of pattern that we see outdoors. And so drawing students' attention to that, and then they start to see connections between the branches and the roots, for example, for this particular large tree. So again, here's the 10 outdoor learning practices that I shared here with a focus on mathematics. And I hope that some of those are resonating with you as something that you might try with the students that you learn and care for. So I hope you found some inspiration for taking mathematics learning outdoors. And again, if you would like to follow up with me with any questions or like to share things that you've tried with me, here are some ways to contact me. And thank you for joining me today.